This lesson is a continuation of the similarity and congruence video, but now I'm going to talk specifically about congruence and triangles. So the first thing that we're going to look at is what it actually means for two figures to be congruent, which we did discuss in the similarity and congruence video, but I just wanted to make sure that we really hit this point home. So they're congruent if they have the same size and the same shape, and this only happens if I can do a rigid motion to get from one image to the other. So I'm talking about going from the pre-image to the image, and this was, as we stated in our other videos, this is where I'm talking about the isometries that we are allowed to use. So reflections, rotations, and translations. And those are the only types of movements I'm allowed to use when I'm talking about creating congruent figures. The other really important theorem that we're going to use in this video is CPCTC for short, or corresponding parts of congruent triangles are congruent. And what that means is if I've been given two triangles that are said to be congruent, then the angles that relate to each other are congruent and the sides that relate to each other are congruent. The difference between yesterday and today with our similarity and now today our congruence, yesterday when I was talking about similar figures, the angles that related to each other were congruent. However, the sides that were related to each other were proportional, and I created that fraction or that ratio of the sides. Here it's a different story. Here the sides and the angles both have to be congruent. So let's look at an example. So if I was just going to talk about the corresponding parts, you could write me 6 statements about these two triangles. So I have triangle RGF, and we know that that's my congruent symbol. So they're saying RGK is congruent to MQB. So if I'm going to talk about corresponding sides, I'm going to start with, let's say, RG. In order for me to talk about the line segment on the other triangle that is corresponding to RG, I have to be very, very careful with the order. Because R came first in this statement, it has to correspond to the first vertex point in the other triangle. So if I'm going to do RG, I could say that would be congruent to line segment MQ. Because this is the first two vertice points on this triangle, which means MQ is the one that matches up because they are the first two in the second one. The other statements I could make, I could say GK is congruent to, so that's the second and the third. So now I take the second and the third out of here, and that would be QB. And the last one that I'm going to say is KR is congruent to, now I have to take the last one and the first one. Let me move these over so I have a little bit more room. And the other important thing to note here, you could, this was BM, you could have had all of these flipped completely backwards. So you could have said RK, but I'd have to flip this one backwards as well and say MB. And if I did that with GK and I said KG instead, I have to flip this backwards too. So now let's talk about our angles. So I'm going to say that angle R, whatever the measurement of that angle is, would be congruent to angle M. I can say that angle G would be congruent to angle Q, because those are both listed in the second position. And I can say that angle K is congruent to angle B, because these all correspond with the same position in both triangles. You can think of it as 1, 2, 3, and 1, 2, 3. Your 1s match up, your 2s match up, and your 3s match up. So I'm going to leave you in this video with two different questions. This is the first one that I'm going to leave you with. So a student claims that two congruent triangles have the same perimeter, and any two congruent triangles have the same perimeter. One thing I want you to try to answer before you come back to class is, do you agree or disagree? And be able to defend why you agree or disagree. So this is one thing we're going to talk about when we come back to class. And the next one I'm going to leave you with is this picture here, and I'll make this larger so that you can see it in the video. So I've given you triangle ABC, and I've given you triangle DEF, and your mission is to find the length of AB and the measure of angle E. And I'm going to challenge you one little step further. See if you can fill in all of the missing pieces on both triangle ABC and triangle DEF. And this is where we're going to start when we come back to class together. If you have any questions about anything that was in this video, any of the theorems or examples, please make a note in your notebook and bring it to class with you when we return.